Hello, Sandberg Algebra students. This lesson is on factor by grouping. This method is very important for a future method you guys probably learned known as AC method. Factor by grouping is the easiest to notice when you have to do it. You know, we always start with the greatest common factor, but anytime you have four terms, all right, the first thing you want to do is always start with the GCF, but then if there's no greatest common factor, move on to grouping two terms and factor by grouping. So anytime you see four terms, first thing you want to do is make sure it's in standard form and then group two terms and two terms. Okay. Now, once we group these binomials, what you're going to do is look for the greatest common factor in each one. So I look at this first binomial. Greatest common factor between 6 and 9 is 3. And then you have n to the third and n squared, so you can pull out at least two n's. So our greatest common factor for this binomial is 3n squared. So when I divide by 3n squared, I end up with 2. N to the third divided by n squared is n, plus 9n squared divided by 3n squared is just going to be 3. Now in the second binomial, I have 8n and 12. Greatest common factor is positive 4, and they both do not have an n, so I cannot factor out an n. So I divide by 4, and I end up with 2n plus 3. Now, what you should notice here is the two binomial factors should match up. If they don't, all right, you did not group properly. So once these binomial factors match up, what we're basically going to look at is, this is a term and this is a term. And it's almost like we're doing the greatest common factor again. What is a common factor between this term and this term? Well, it's 2n plus 3. So we pull that 2n plus 3 out, and if we were to divide both of these by 2n plus 3, what happens? The 2n plus 3's cancel out, and what do we have left over here? 3n squared. What do we have left here? Plus 4. And that is how we factor by grouping. And again, do we use this a lot? No, but an easy way of teaching, factoring quadratic trinomials when a is not equal to 1 is using a method called AC method. And this part of grouping is part of that process. So next example. As soon as I see four terms, I look no greatest common factor. So I group the first two and the last two terms. Okay, and I look, what is the greatest common factor between 2r to the third and 7r squared? Well, 2 and 7, no common factor, but r squared. And if I divide by r squared, I'm left with 2r to the third divided by r squared is 2r plus 7. And then over here, between 4 and 14, 2 is the common factor. So when I divide by 2, I end up with 2r plus 7. First thing I check for, do my binomial factors match up? And we are happy here, therefore we can go ahead and factor. What are the common binomials? 2r plus 7. And what do I have left over here? R squared. What do I have left over here? 2. Okay, let's do a couple more examples. Okay, four terms here, no greatest common factor, even though it looks like there isn't. And if I group first two and last two, common factor between 25 and 15 is 5. Between x to the third and x squared, I always take the smallest exponent. When I divide by 5x squared, right, I end up with 5x here. 15 divided by 5 is 3. The x squared is eliminate. So 5x plus 3 is the leftover binomial. Now, here's the key. Notice how this term is negative. If the leading coefficient of the second binomial is negative, not only do you have to factor out the greatest common factor, but you must make sure you factor out that negative. So if that's negative, we pull it out. Common factor between 30 and 18 would be 6. Each term does not have an x, so we cannot pull out any x's. So we would use negative 6 as our GCF here. Now think about it. Negative 30 divided by negative 6 is going to be positive 5x And then negative 18 divided by negative 6 would be positive 3. Now, you know you did it right, alright, as if these two binomial factors match up. Now, if you didn't factor out the negative, this would have been negative 5x minus 3, and they wouldn't match up. So that's a way to know if you did it right or wrong. We did it right, so now we can factor out the common binomial factor, which is 5x plus 3. And what do I have left here? 5x squared, and then minus 6. And again, just like any factoring method, you can always check your answers real quick just by multiplying the binomials out. 5x times 5x squared is going to give you 25x to the third, minus 30x plus 15x squared, and then 3 times negative 6 is negative 18, and there would be no like terms to combine, so you know you are correct. So look at this last one here. Okay, 4 terms, no GCF. Group, 7x squared would be the GCF here. And when I divide by 7x squared, I kind of like students to show that so that they do the mathematics correctly. 7 divided by 7 is 1, x to the third divided by x squared is x, minus 14x squared divided by 7x squared gives you 2. And then here, again, look at that. That's negative. So not only do we have to factor out the greatest common factor, but we have to factor out a negative also. Common factor between 8 and 16 would be 8. And when I divide each term by negative 8, negative 8x divided by negative 8 is positive 8x. Oh, sorry, positive x. Okay, and then 16 divided by negative 8 would be negative 2. Do my binomial factors match up? Yes, they do. So I pull out that common binomial factor, x minus 2, and when I cross them out, what do I have left over here? 7x squared minus 8. And we are done. Okay, it is your turn to do the next set of problems, and feel free to rewind if you need to look at how a problem is done. Thank you for your time.